Welcome everyone. Today we're going to be looking at position. It's part of our section on motion in one dimension. It's very exciting, so let's just get right into it. So, have you ever thought about this? Is it possible to run a race and yet have gone nowhere? And I don't mean running on a treadmill, but actually on the road, running a race, running around the suburb, and yet in science terms, you've gone nowhere. That sounds a bit weird, but it is possible. So we're going to talk about that. All right, so we've been looking at motion in one dimension. We've looked at vectors and scalars, and we're now going to look at frame of reference and position today. So here we go. Here are our keywords. Frame of reference, that's very important, which is a new term. Position, distance, and displacement. Those three, but position, distance, and displacement are related to each other. And we're going to see that today. So let's look at frame of reference. When we look at the frame of reference, we have to look at what the definition is, okay? And defining a frame of reference feels a little strange because it's not something we normally do, but you actually do it instinctively in that you always look at the world from a certain point of view. And that's what we're talking about, is we're going to define where we're looking at the motion from, because that's really important for us to describe it. So we're looking at motion in one dimension. We're going to look at movement in one plane. In other words, what I'm telling you is when we look at motion in one dimension, I'm only going to look at things that go backwards and forwards, horizontal, okay, or things that just go up and down. We're not going to take something that's going to go at an angle. Not yet. We'll add that in later. So motion in one dimension means one plane, one parallel motion, okay? So backwards, forwards, up, down, not together though, okay? Which is what I've just told you. So when we look at frame of reference, this is our definition. It's a reference point. So the frame of reference is the point from which the position of an object is measured. So if I want to look at me to my screen behind me, I can be the reference point, okay? If I'm considering me to the camera that's in front of me, I can either go, I'm the reference point, or the TV, the screen is the reference point. I have to know where I'm measuring the distance from so I can describe it properly, okay? It's the same as when you give directions. You sometimes go, no, just turn left, then turn right, but you've got to tell them where. And you've got to tell them relative to what. What are we looking for, okay? Ooh, there we go. Let's look at position, displacement, and distance, because they go together. So position can be described as a displacement or a distance. Displacement is a vector. So when I look at displacement, it's actually how my position has changed compared to the starting point. So have I gone 20 meters to the right of where I started? Have I gone 30 kilometers north from where I started? So displacement is how the position changes. Distance, I don't care how you did it. Distance is I went 20 meters. I went 30 kilometers. Okay, distance doesn't care about which way we went. And that's actually how races work. You can run a half marathon, heaven forbid, 21 kilometers, but if the start line and the finish line is in the same place, you may have run, or in my case, walked 21 kilometers, but you start and stop, you actually have zero displacement. So in science terms, you did nothing. This is why I don't like running. Okay, so position is the place where an object is relative to a reference point, where we're measuring it from. Distance is the length of the path followed by a moving object. We don't care how it gets there, okay? Displacement here we go, is the difference in position with respect to the starting point. That's the important thing here. We need to know where the starting point is. I need to know where did I begin. Because if I know where I began, then I can get to an idea of where I'm going, okay? It's the same thing as when we go, I'm hoping you've heard this saying when somebody says, as the crow flies, it's 20 kilometers away. And you're like, okay, what does that mean? That means if we could fly over all the buildings, it would be 20 kilometers. In fact, when satellite navigation and GPS things first came out before we had them on our phones, it was very frustrating because the directions they would give you, and they'd say, okay, you've got to go 30 kilometers, it's going to take you 10 minutes, because they would always go how far, like if I could just jump over all the buildings, I'd get there, it would take 10 minutes, but we can't. So I often had to put extra time on there. Phones are much better now. Plus, they can tell us traffic and all sorts of things, okay? So, we've now covered frame of reference, position, distance, displacement. We're going to look at all four of those in lots and lots and lots and lots of detail. And we have to get into our heads the difference between if I'm saying position or distance or displacement, okay? So, time for a short break, and I'll see you in a couple of minutes.